All right, so next up we have dividing radicals, which includes rationalizing because we know that we're not allowed to have radicals in the denominator of a fraction. So when I'm looking at these, basically the rule is that when you have a fraction inside of a radical, you can break it up into two smaller radicals. So you can either divide the two radicands first and then take the radical, or you can take the radical of each part of the radicand and then divide them. Okay, so it doesn't matter which way you do it. So when you're looking at these, your best bet is almost always to simplify like a fraction first. Okay, so like this guy right here, I'm going to do this out with all the steps, which I wouldn't normally do, right? According to this rule, I can rewrite this as the square root of 10 over 15. And then, since 10 over 15 simplifies like a fraction, I can rewrite that as 2 over 3, right? Which is then the square root of 2 over the square root of 3. And then from there, I just need to rationalize this, which you remember how to do. Multiply top and bottom by root 3. And I'm going to get the square root of 6 over whole number 3. Okay, now I wouldn't show all these steps out, honestly. I would jump from here to here, right? And then just rationalize it from there. But that's the general process of what we are doing here. Okay, so we look at this next guy here. I'm going to start by simplifying that like a fraction. So 6 over 12, I can simplify that to the cube root of 1 over the cube root of 2. And then the part that you need to watch out for, this is the common mistake that I see all the time. To rationalize this, we need to make this bottom number a perfect cube. Okay, so 2 is obviously not a perfect cube. So to multiply this to make it a perfect cube, I'm not going to multiply by the cube root of 2 top and bottom. I have to multiply by the cube root of 4 top and bottom because 2 times 4 is 8, and 8 is a perfect cube. Okay, so that is the piece that you need to watch out for. When you're simplifying, rationalizing with just a square root, it's just you can always use the same thing, but you can't do that most of the time when you're looking at any other radicand. Okay, so now on the top, I'm going to have the cube root of 4, and on the bottom, I have the cube root of 8, but the cube root of 8 is 2. And there's my rationalized expression. Okay, this next guy here, so the cube root of 8 over 9. So I can start by breaking this, right? The cube root of 8 on the top is just regular old 2. And then I have the cube root of 9 on the bottom. So what I'm thinking to myself is I'm thinking, okay, 9 is 3 times 3, right? So I have 2 3s. I need to have a set of 3 3s, right? So I'm going to multiply by the cube root of 3, top and bottom. Okay, so then I'm going to have on the top 2 times the cube root of 3, and on the bottom 9, so that's 3 times 3 times 3. The cube root of 3 3s is just a 3. And that's it. Those 3's not going to cancel out because one's inside of a radicand and one is not. All right, this guy here, again, I'm going to start by simplifying this like it's a fraction. So 28 over 4, we can simplify that to 7 over 1, right? So I can simplify this to the square root of 7, 3 a's on the top and 6 a's on the bottom, right? If you remember your radical rules, 3 of them will cancel out. So I'm going to be left with just 3 a's on the bottom. Okay, and then 2 b's on the top and 4 on the bottom is going to leave me with 2 on the bottom. Okay, and then we're talking square roots here. So I'm looking at this and I'm trying to think about how I'm going to rationalize it. So to rationalize this, the square root of b squared, that's already going to take care of itself. The square root of a to the third, I'll pull out a set and I'll have 1 left over, right? So all I need to multiply by to rationalize this is 1a. And then on the top, I'm going to have the square root of 7a. On the bottom, I've got the square root of a to the 4th b squared, which simplifies to a squared b. And again, the a's don't cancel because one is inside the radicand and one is not. All right, this next guy here, okay, so I want to just make sure you see visually what the differences are in these next 3 problems. So notice how in this problem, it's 1 giant square root on the bottom versus these ones where it's 2 separate pieces on the bottom. So this, both parts are inside the radical. These ones are separate parts. Okay, so that's a key difference here. So for this guy, when I want to simplify him, okay, I just need to get the stuff on the inside to be a perfect square. So I'm going to multiply by the square root of x plus 2. Okay, because the square root of x plus 2 times x plus 2 is just x plus 2, right? So that's going to simplify to just x plus 2 on the bottom. And then on the top, I'm going to do distributive property, 3x plus 6. Okay. This next guy here, okay, so the difference between these two, again, this one is all inside the radical, this one is partly outside. Because this one is a mix of a regular number and then an irrational number, I'm gonna need to use a conjugate. Remember our good friend the conjugate? So I'm gonna multiply top and bottom by 1 minus the square root of 2. Okay, because that is a conjugate pair. So these two have to be conjugates. Okay, so when I do that, the top part gets a distributive property. It's going to be 3 minus 3 root 2. And then on the bottom, I know I'm going to get 1 times 1 is 1. Then I'll have the 1 times negative root 2, and then the 1 times positive root 2 that'll cancel each other out. And then it's going to be minus the square root of 4. So square root of 4 is 2. 1 minus 2 is negative 1. And then we can simplify that just by dividing everything by a negative. That's going to be negative 3 plus 3 root 2. And there we go. All right, and then last one here, again, I want to have a conjugate, so I'm going to multiply this by 4 plus root 3. So on the top, distributive property, I'm going to get 4 times the square root of 3 plus the square root of 9. We'll come back and clean that up in a second. On the bottom, 4 times 4 is 16. My two middle terms are going to cancel. And then it's going to be minus the square root of 9. These do not cancel each other out. That's not a thing. Don't do that. Okay, but I can simplify this. The square root of 9 is 3. And in the top, we usually put the term with the radical at the back. So I took the square root of 9 and made it a 3 in the front, and I put this guy in the back. And then on the bottom, it'd be 16 minus 3. So that's 13. And there we go. Okay, so that is how you divide radicals and rationalize them. Okay, because remember, you're not allowed to have a square root in the bottom or any other kind of radical in the bottom. And the big thing that you need to watch out for, right, just to recap this part, this is the part that people mess up a lot. Okay, you can't just multiply by the exact same thing. You have to multiply by a number that's going to get you to a set of whatever you need. So I had to multiply here by 4 because that gets me to 8, which is a perfect cube. Here I had to multiply by 3 because that gets me to 27, which is a perfect cube. Okay, so those are the pieces that you really have to make sure you pay attention to.